Alright, so we're wanting to find all the zeros of a function given a zero of the function. So this is the function that we're given, x cubed minus 7x squared minus x plus 87, and the given zero is 5 plus 2i. Since this is imaginary, I know that the conjugate, if you recall when we talked about complex numbers, the complex conjugate is also a zero. So I know, just starting off, x equals 5 minus 2i is also a zero. So I got two of them so far. So let's go through and use synthetic division to break this down to figure out what the last zero is. So I'm going to set this up. 5 plus 2i is my zero, or my root, so that's going to go on the outside. And I have all of my terms in order. So in synthetic division, just using my coefficients, 1, negative 7, negative 1, and 87. And so synthetic division with a complex number works exactly the same as synthetic division with a real number. So I'm going to bring down my first term. I have 1. Multiply 5 plus 2i times 1 just gives me 5 plus 2i. And now I need to add. So adding complex numbers, just combining our like terms, real number with real number, and then imaginary with imaginary. So negative 7 plus 5 gives me negative 2, and I don't have another piece, negative 7, so my 2i just comes down. So now I have negative 2 plus 2i, and so I need to multiply again. So I need to multiply 5 plus 2i times negative 2 plus 2i. So I'm going to come over here to the side and multiply that out. I need to do 5 plus 2i times negative 2 plus 2i. So distributing, I get negative 10 plus 10i minus 4i plus 4i squared. 4i squared just turns into negative 4. So combining like terms, negative 10 minus 4 is negative 14. And 10i minus 4i is positive 6i. Check my arithmetic. I think we're good. Yes. Yes, sir. All right. So we have negative 14 plus 6i. So putting that over, negative 14 plus 6i. And combining my like terms, so negative 1 plus negative 14 is negative 15. And bringing down my 6i. And again, multiplying, so 5 plus 2i times negative 15 plus 6i. So again, I'm going to come over here to my scratch paper and multiply that out. I have 5 plus 2i times negative 15 plus 6i. Now, I already know that 5 plus 2i is a root, so as long as all my previous arithmetic is correct, I should get negative 87, because these have to cancel out and give me 0, right? Because I know it's a root, I know my remainder has to be 0. So if I get negative 87, then we did it right. All right, so let's multiply. 5 times negative 15 is negative 75. 5 times 6i gives me positive 30i. 2i times negative 15 gives me negative 30i. And 2i times 6i gives me positive 12i squared. Positive 12i squared is negative 12. Now combining like terms, my two middle terms cancel out. 30i minus 30i is 0. And negative 75 minus 12, ta-da, gives me negative 87. So negative 87, add, I do get 0, which I should because 5 plus 2i is a root. So I've reduced it down to this horrific looking-ish quadratic. So now we'll use this, and I know that the conjugate, 5 minus 2i, is also a root. So now let's do it again. Using the new function that I came up with and my second root. So 5 minus 2i on the outside. I'm going to get good room going on here. I have 1, negative 2 plus 2i, and negative 15 plus 6i. Alright, so same thing, a little synthetic division. Bring down my 1, multiply 5 minus 2i times 1 gives me 5 minus 2i. Negative 2 plus 5 gives me 3. And 2i minus 2i luckily cancels out, so I get 3. Multiply again. 5 times 3 gives me 15. Negative 2i times 3 gives me negative 6i. And look at this fanciness. Negative 15 plus 15 is 0. And 6i minus 6i is also 0. And this is my remainder. Again, I should have gotten 0 because we knew 5 minus 2i was also a root, since 5 plus 2i was. And so I did synthetic division twice with 2 roots. I started with a cubic. After I did it the first time, I essentially reduced it to a quadratic. So what do I have now? Linear, right? So this tells me that x plus 3 equals 0. Equals 0 because I want to solve it, right? If it was a quadratic, we'd set it to 0 as well. So x plus 3 equals 0. And if I solve for x, I get x equals negative 3. And so all the zeros of my given function are 5 plus 2i, the given root, 5 minus 2i, the conjugate, and x equals negative 3. So these are all the zeros of my given function.